Welcome all. In this video, we are going to learn how to convert a truth table into canonical product of sums expression. As I had earlier told you that there are two specific formats, SOP, POS. In POS format, multiple OR gates are combined together in a single AND gate. Okay, now we have to write the Boolean expression in POS format from the given truth table. Now, how can we do it? First step is, here we will identify rows that contain 0 as the output. This is the truth table. We need to identify the rows where the output is 0. So these rows are 0th row, then 2nd row, then 5th row, and then 7th row. Now, how will we write the sum terms? Now, after identifying rows where the output is 0, we have to write the sum terms for each of these rows. Okay, now how to write sum term? See, if the value of the variable is 0, it will be written as it is, that is in uncomplemented form, in a sum term, fundamental sum term or max term, because we need to make the sum of all variables equal to 0. So now we will consider this 0th row. The value of the variable is 0, so it will be written as it is in the sum term. A plus the value of the variable is 0, it will be written as B, A plus B, plus the value of C is 0, so it will also be written in uncomplemented form. So first term corresponding to this 0th row is A plus B plus C. This is the sum term, fundamental sum term or max term. Now we will identify another row, which is the 2nd row, and write the sum term for this row. The value of the variable A is 0, it will be written as it is. As the value of the variable B is 1, so it will be written in complemented form in a max term. So we will write A plus B bar, we will put a bar over the variable B, plus C as it is, because its value is 0. Next we will identify the row number 5th and write the max term or sum term for this row. It will be A bar plus B plus C bar. For the 7th row, sum term, fundamental sum term or max term will be A bar plus B bar plus C bar. Okay, now ANDing all of these sum terms to obtain the POS expression of this truth table. So when we AND A plus, first sum term is A plus B plus C, then it dot A plus B bar plus C dot A bar plus B plus C bar dot A bar plus B bar plus C bar. 4 sum terms, then we will AND them together to obtain the POS expression. Alternative way to write a POS expression, we can also write it in the shorthand notation of max term. Each max term is designated by a suffix. The suffix I had earlier told you corresponds to the decimal equivalent of the binary pattern. So if the sum term is A plus B plus C, it means the binary pattern is 0, 0, 0. So it corresponds to decimal 0. If the binary pattern, if the sum term is a plus b bar plus c, it means the binary pattern for this sum term is 0, 1, 0. A is the MSP, C is the LSP, 0, 1, 0. So decimal code for this binary pattern is 2. Decimal code for this binary pattern 1, 0, 1 is 5. Decimal code for this binary pattern is 1, 1, 1. That is 7. So we can write it as M0 dot M2 dot M5 dot M7, or there is one more way. Write the product sign, then max, M, capital M, denoting the max term, then their subscript 0, 2, 5, 7, or you can say the rows where the output is 0. Okay. Now, moving on to another slide. How to obtain canonical how to obtain canonical POS expression. Wait, please. Okay, sorry for the disturbance. Now I think the screen is clear to you and it's quite visible. Now, how to obtain canonical POS expression? Suppose we are being given this expression y is equal to a plus b bar c. Now, first of all, you convert it into POS. Okay, use the distributive property of OR gate. OR is distributive over and a plus bc is equal to a plus b into a plus c. So here b is, substitute b bar for b, so we can write a plus b bar into a plus c. Now, what can we do? In the first term, variable c is missing. In the second sum term, variable b is missing. So to obtain canonical terms, canonical sum terms, fundamental sum terms, multiply. Okay, so not multiply, add the product of missing variable and its complement in the non-standard sum term. Repeat this step until all the sum terms in the logic function are fundamental. They become fundamental and contain all the variables. So what I have done here, a plus b bar, I have added the product of the missing variable and its complement. We know that c dot c bar is 0, and when 0 is added to any variable, 0 is odd with any variable, the result will be the original variable. So the result will be a plus b bar. So it will not make any difference to our expression and the expressions remain equivalent. Sorry. Okay. Now a plus c, right, a plus c plus b dot b bar. Now again apply distributive property, substitute x for a plus b bar, y for c, z for c bar, and write it as a plus b bar plus c into dot a plus b bar plus c bar. Substitute x for a plus c, y for b, and z for b bar. X plus yz is equal to x plus y into x plus z, so that a plus c plus b dot a plus c plus b bar. Now we can see that the first term and fourth term are equal. OR gate is commutative and associative, so write it once because a dot a is always equal to a, so write it only once. Then second term and third term. Now what you will do, arrange these variables so that you can write the subscript of the next term clearly. So A is the MSP, B is the middle term, and C is the LSP. So we can write it as A plus B plus C because OR gate is commutative and associative. Now write it in the max notation. Now this corresponds to 0, 1, 0. Then M2, 0, 1, 1, M3, 0, 0, 0. So M0, or you can arrange it M0 in ascending order, M0, M2, M3, or you can write it also in Y is equal to product sign M0, 2, 3. Thank you so much for listening carefully.